Hello everybody and welcome to Epic Pencil and Paper. Today I'm going to show you how to do a nonogram. A nonogram is a fun puzzle where you figure out which squares you fill in on a grid and which squares you don't fill in, and then you get a fun little picture. And nonogram puzzles can be any size. They can be thousands of squares by thousands of squares. But for today we're going to start with a grid that's 15 squares by 15 squares. 225 squares altogether. It's a very small one, but it's a good one to start off on. I'd suggest you start on small ones and work your way up to the bigger ones. The bigger ones are more difficult to do, but also way more satisfying. So each of these rows has 15 squares in them. These numbers tell you how many squares in a row are in each row. So this means there's 13 squares in a row. This one, there's one square that's 4 in a row and another one that's 4 in a row. And we know that there has to be at least one space in between the 4 and the 4. Are you with me so far? Okay, so if this was a 15, we would know that this entire row is filled in. But alas, it's a 13. But that's okay, because we know that no matter where the 13 is on here, some of the blocks in the middle are going to be filled in. And I'm going to show you a really easy trick to figure out how to figure out which squares in the middle are filled in. If we count 13 this way, that'll take us to here. If we count 13 from the bottom, that'll take us to here. That means that all of these squares in the middle must be filled in. Great. Now those are filled in. Now we know that this one here has to be part of that 3. And this one here has to be part of that 3. And this one here has to be part of that 2. So that lets us know what a bunch of the numbers are and gets us started on our way. Now, I filled in the 3 here and the 3 here. That means this can't be anything. So we can put an X there, because we know that these 2 squares must be empty. Now, it's a good idea, once you've found the numbers, to cross them out. All right, now we have 4 in a row here, and there's only 2 4s. That means that these 2 spaces must be empty. And we only have room for 2 more here, and there has to be another 4, so that means we found both of the 4s on this line. We know that this one is a 2, because it has to be. There's only 2s in this one. And we know it's the upper 2. Now, we know that this square here has to be part of this 3, and this square here has to be part of this 5. Now, the furthest this 5 can go would be here. And that's the farthest to the left it can go. The farthest to the right it can go is here, which means that these spaces here must be 5. If we count from here, 1, 2, 3, 4, 5, we know that the 5th part is either here or here. We don't know which, but we know that these squares are going to be filled in for sure. Just like we know this one here is going to be filled in as part of the 3. And now from this row we know that these 2 are 1s. So we can put X's here. Now by putting an X here, we know that this is the 3rd square in the 3. Now, this row here only has a 1 in it. And that's it, and we've gotten that one. That means the rest of this row is just X's. We've also now gotten both of the 2's in this row, which means the rest of this row is just x's. Now, since we've found another square in the 13, we know that the farthest that the 13 can go is this way. If we count from this, if this was, say, the bottom of the 13, go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which means that this can't be part of the 13. But we can also cross this off by looking over here and knowing that there's only a 7 in this row, and 7 couldn't fit into that one space. So no matter how we look at it, we know that this square here is going to be x'd out. We can also deduce that this one's going to be x'd out because of this 7, which means that this square here has got to be part of the 13. Which means we've solved both this 13 and this 5, and we can put an x here. Now, 4 of the 15 squares in this row have been x'd out. That means there's only 11 spaces left that can be part of the 7. Now 7 times 2 is 14, and 11 is shorter. 11 is less than 14. So that way we know what some of these are going to be part of the 7. If we count to 7 this way, it takes us to here. If we count to 7 from this way, it takes us to here. That means these 3 squares must logically be filled in and be part of the 7. That way, from knowing what these 3 squares are, we know that this is going to be 6, and that this is going to be 5, and that this is going to be 5, so we can fill those in. Now, for this 10, it's the same thing. If we count 10 this way, it takes us to here. If we count 10 this way, it takes us to here. Now here, we have a square here, and we know that the 2's already been used up, so this must be a 5. And because the 5 can't go anywhere this way, we know that the 5 must go this way. There's only 5 squares here. All 5 of these squares are filled in, which means that everything on this side is all x's. It's nice every once in a while to take a look at what squares we filled in and look at the picture and go, can we tell what the picture is yet? And no, so far I cannot tell what this is a picture of. But we'll find out soon enough. Alright, now we know that this one must be part of the 6. If we count this way, 1, 2, 3, 4, 5, 6, it takes us to here. And it's going to be the same thing in this row, and the same thing in this row, which means all of these squares here are going to be filled in. Now, this 9 here, we've already discovered 4, 5, 6 pieces of the 9, right? So this is 6. The farthest it could go this way is 7, 8, 9 up to here. That means this one cannot be part of the 9. Same with the 7. Farthest the 7 can go to the right is here, which means the rest of it is x's. Now take a look at these 2's here. If this was a 2, 1, 2, then this one couldn't be filled in. It would have to be an x. So that way we know that this is part of the 2, which means that these squares here have to be x's because they can't be part of the 2. By filling in those 2 x's, we learn that this is where the 7 goes. So now we've solved the 7. 1, 2, 3, 4, 5, 6, 7, and the rest of the row is x's. Now we filled in the rest of this row for 7's. We know where all of these 6's are up here. And let's not forget to put X's at the end of the 6's. And cross them out. Alright, now we're really getting somewhere. Now we know where exactly this 9 ends, which will be here. These 2's have been solved now, as well as this 1 in this row. Now, we can figure out where some of these squares in the 7 is going to be. 1, 2, 3, 4, 5, 6, 7. It's going to go take us to there, and 1, 2, 3, 4, 5, 6, 7 takes us to there. Which tells us what all of these numbers on the left are. We know that this is a 1. We know that this is a 4. We know that this is a 2. And a 3, and a 7, and a 5, and we can fill all of these in. Alright, now we've gotten both of the numbers in this row and this row, so the rest can be filled in with X's. We're getting really close to finishing this puzzle now. I still can't tell what it is. Can you? Alright, well, we know that needs to be a 6 here, and if we times 6 by 2, then we get 12. So if this is less than 12 spaces, then we've got a big clue. And of course, this is 9 spaces. So if we count this way, 6 will take us to here. And if we count from this way, 6 will take us to here. So we know that these 3 spaces here are going to be filled in. Okay, that means we've finished off this 1 and both of these 3's. Now, because this is a 1, and we have this one here, we know that this must be the next one, which means we have 1 left somewhere in this row. Now here we've got a 3, a 2, and a 6 in this row. We've already gotten the 3 and the 6. That means this has to be part of the 2, this square here, which means this one can't be part of the 2 because 2 doesn't reach that far. Now, this row has to have a 2 in it. And this is only 1 space, so we know that the 2 can't be there. This row is the same thing. It's supposed to be a 2 can't fit there, therefore this is an X. That gives us a little bit more information about our 6. It lets us know that our 6 is now 1, 2, 3, 4, 5, 6, going all the way to here, which means these 2 squares can be filled in. Now we've finished this 6, and we finished this 4. Those can be crossed out now. Now we also know that this is a 1. And that row is finished. So is this row. We've gotten both the 6's, that row is finished. Now, here, this row has a 2. We know that this can't be a 2, and that means that this one must be a 2. And we know that this is the last part of our 6, which means we can cross off our 6 and our 7. Like to do a little touch-ups as we go along. You don't have to be neat with these puzzles, but now, as you can see, nonograms are always put in blocks of 5. So we've done all 3 of these top blocks, and we've just got a few more left to go. We're almost done the puzzle. Okay, so this row, we've finished the one on the left and the one on the right, so we've got a 4 and a 1 left. So let's try this. If there was a 1 here, then there would have to be an X here, which means the 4 could be anywhere in this area here. So if we count 1, X, 1, 2, 3, 4, the farthest we can go is this way. Counting 4 this way, 1, 2, 3, 4, takes us to here. That means that these 2 squares here where I've just put dots must be part of the 4 and should be filled in. It's logic. That means we've gotten our last one from this row and can fill in the rest with X's. This is part of a 2, which means this one is an X. That's what we learned from filling in those 2 squares. Now, the very first number in this row is a 3, which means this can't be the 3, because there's only one space there. That means there's going to be a 3 and a 1 fit into this space. And if we look, 1x, 1, 2, 3, we can see that's all there's room for. There's only room for a 3 here, a 1 here, and an x here, which means this row has been solved. All right, so now we know that this is the rest of our second 3 in this row, which means this row is now finished. Now that means that we know that this is a 1 and this is a 2. And this is our final 2 here. These are also 1s, so that's the end of that row. Now this has got to be part of this 3, which means this is an X and this is an X. This has got to be the 2, 1, 2 here, because it's obvious. There's only 2 squares left blank in this row, and it's a 2. That means both of these are filled in. This is our 3 here. This is our 2. And we can see now that our 4 is here. And this is a 2. And I believe that's the last square in the puzzle. So now this puzzle is solved, and as we can clearly see, it's a bunch of bananas. And that nonogram has now been solved. All right, so thank you for watching. Now go out there and do your own nonograms and have fun. If you like this video, please give it a thumbs up and subscribe for more great pencil and paper videos on Epic Pencil and Video. Wait, no, that's not the name of the channel. On Epic Pencil and Paper, the channel with videos. There you go.